Assalamu alaikum warahmatullahi wabarakatuh. Subject Computer Science for 11th Standard A section. Last class we started chapter number 6 Algorithm Problem Solving. Now we are in the second part of this same chapter. So last class we discussed three important topics of this lesson, namely algorithms, algorithmic problems, and building blocks of algorithm. So now in this session we are going to learn the algorithm design techniques, specification and abstraction. Now we are in the first topic of this part, algorithm designing techniques. There are four important techniques used in algorithm designing techniques. Number 1, specification. Number 2, abstraction. Number 3, composition. Number 4, decomposition. So we will see one by one. Of course, we on in previous class we learned what is algorithm. Simply we can say algorithm is the step-by-step procedure to solve your problem, and variables, statements, control statements, sequential statement are some of the building blocks of the algorithm. Now we are in the algorithm designing techniques. The first technique is called specification. So before we start writing an algorithm, first we want to know what is the exact problem. So before we start any work, we should know what we are going to do and what will be the final output and what we want from this process. So if we want to know the correct problem of any problem, then we should follow these algorithm techniques. So for example, if you take a civil engineer who construct buildings, when you approach any civil engineer for constructing building, then he asks to submit some questions about your requirement. For example, how much of space you have, and what are the things you need, and what are your requirements, what are your problems, and after that, analyzing all the answers given by you, he come in a conclusion, and that conclusion becomes the specification of any civil engineers. For example, if you want to solve any problem, then you should understand that problem, then only you can create the solution for that problem. For example, if you take a doctor, when you approach any doctor for any health complaint, then he first try to diagnose your problem, analyze your problem by giving many testings, blood test, urine test, or any testing. By depending upon the results of the testing, he come into a conclusion of what type of treatment should be followed to you. So they are depending upon the patient to patient, depending upon the problem to problem, the specification may vary. So the specification is nothing but knowing the exact problem and come into the conclusion what are the exact inputs and what will be the desired output. So here in this statement you can see the specification must also state the properties of the given input and the relationship between the input and the output. So in specification technique, so what we want to do, we analyze the problem thoroughly and come into the conclusion what are the inputs we required and what will be the output, and we should know the relationship between an input and output of any program which we are going to develop for the user. So next technique is abstraction. So what is abstraction? So when we try to solve any problem, at the time of executing the instruction, there are many things are to be done. So at that time, all the unnecessary details and modeling should be ignored and hide from the user. This type of technique is called abstraction. For example, when we represent the state of process, we select only the variables essential to the problem and ignore inessential details. Again, we take an example of civil engineer. When any civil engineer try to construct a building according to the requirement of the customer, he start its work. At the time of work, he only consider what are the bricks we use, what are the cement and other elements we use for construction, and how much of space we require for constructing a wall, and what is the space we allotted for different rooms, and these are the elements he discussed. But he didn't get into the deeper details like what type of sand is used for making bricks, what type of iron material used for making rods. So this is the thing which are which are ignored and hide from the programmer user. This type of hiding the unnecessary items will lead you to create a good solution for your customer's problem. So abstraction means, generally we can say, the unwanted things. When we try to avoid the unwanted things and ignoring the unwanted things, this technique called abstraction. So again, I'm going to give a second example. When you want to learn driving, then we should know what is the use of accelerator, what is the use of brake, what is the use of gear, what is the use of steering. But we didn't get into technical details like how gear works, how accelerator work, what will happen inside machine when I press excess amount of accelerator, what will happen inside any engine when I press brake, what will happen when I turn a uh, gearbox from in the wrong direction or any type of right direction. These are unwanted and ignorable details which should be ignored by the learner who try to learn the driving. So he should know the necessary things for driving. So this is called the abstraction. So abstraction is a technique where we ignore or hide the unnecessary things for our programming. So next technique is called composition. What is composition? An algorithm is composed of assignment and control flow statement. A control flow statement tests a condition of the state and depending on the value of the condition decides the next statement to be executed. So this is called composition. Composition means what? So depending upon the current state, we will decide what we want to execute the next statement. What is our next step? For example, when you are trying to learn driving, then at the time of your traffic, the depending upon the traffic situation, we should use either brake or accelerator. So when we use accelerator when the traffic is less or no traffic, when we use brake for more than one time or many times, it means so brake should be used at the time of traffic. This is simple example which I try to explain the concept of composition. So composition means the analyzing the current state. So depending upon the current state, we will decide what we want to do to the next level in the next day or next step. So next concept is decomposition. So decomposition it is a very old technique called dividing a program into a small group of programs. That is called function, which we already discussed in previous class. It means a function is a subprogram, a subroutine, or a sub algorithm, so which have its own input, which will produce which with its own output. When we try to solve any big problem, then we should divide that big problem into a small problem, and we want to find out the small solution for that small problems. After find outing the small solutions for small problem, we should assemble all the small solutions into a unit, that unit of solution will become a big solution for that big problem. This is called the decomposition. So decomposition means dividing a big problem into small problem and finding the solution for small problems and assembling all the small solutions into a single solution. Then that single unit of solution becomes big solution for that big problem. Now we try to understand these four algorithm techniques in these upcoming topics with different examples. So here you can see the first technique, specification, which we already know what is specification. So specification means we want to decide what type of input we need and how much of input we need and what will be the output and what is the relationship between the input and the output. So here in the example you can see the goal of the algorithm is to establish relationship between the input and desired output. Second point is a algorithm is specified by the properties of given input and relationship between the input and desired output. In simple words, specification of any algorithm is the desired input output relationship. So we try to understand this specification with an example. Here an example called, let there are two inputs, two variables, namely p and q. So here p is the input and q is the output. So what we want to do, we want to know the relationship between the p and q. For that we use a symbol called double dash that indicates the rest of the line is a command. So commands are statements which are used to annotate a program for human readers and not execute by the computer. Commands are crucial points of flow, are useful and even necessary to understand the algorithm. So when we write an algorithm, we can use this double dash symbol for giving a comment about the variable, about a function, about a program. So it is not executable, it is just a hint to the reader. So these are the simple things which we should answer, which we should understand here. So first we want to mention the algorithm name, where we use the inputs. For each an input we should allot the name, and we should decide the output, and every output we should allot the name. That name should be unique and each and every input and output should be related. Now we are going to discuss a specification with an example. Here we are going to create a specification for dividing two numbers. An example you can see 22 is divided by 4 and 15 is divided by 3. When we divide any two numbers, then we will get two output. One is quotient, another one is remainder. When 22 is divided by 5, then we will get the quotient 4 and remainder is 2. When we divide the 15 with 3, then we will get the quotient 5 and remainder is 0. So here what we want to understand, what are the inputs, how the input should be, and what will be the output, how these input and output should be related. So here in this topic you can see a should be an integer. It means a variable. A and B are the input variable and Q, R are the output variables. It means Q means quotient, R means remainder. So here a should be an integer. Remainder is a meaningful only for integer division. So this is the property of the variable, first variable. The number which we try to divide, that number should be integer. Then when we the remainder is meaningful. So this is the relationship between the variable a and the remainder r. So this is the relationship between 22 and the 2. So 2 will produce only when the number is integer. Otherwise the remainder will not produce 0. Next, B should not be 0. That is the second number. This is the A number, this is the B number. So B should not be 0 since division by 0 is not allowed. So of course we cannot divide any number by 0. That's why the second number, that is the number which we try to, the number by which we try to divide this first number, should not be 0. This is the relationship between the B and the quotient. So we will specify the properties of the input as here you can see input A is an integer and B is not equal to 0. So in the single statement, this is how we write specification in algorithm. So this is called double double dash. It means a command. Inputs is a word which refers input variable names, that is A is an integer and B is not equal to 0. So in a single line we specify the relationship between the two variables which we use as input, as well as the relationship between the inputs and the output. So what is the desired relationship between inputs A and B and output Q and R? So we will see what is the relationship between outputs. So in this line we understand how we can write a specification for inputs. So here you can see the double dash we use for command, and we can use the input keyword. After that we can write like this: A is integer and B is not equal to 0. So this is specification which represent all these 3 points in a single line. So next we try to write the specification for the output variables, that is Q and R, that is quotient and remainder. So here the two output Q and R should satisfy the property. So A is equal to Q into B plus R, and remainder should R should be less than the divisor B. So here you can see the single statement where specify the first condition: value of A is equal to quotient into B plus R. So when we multiply the second number with the quotient and add the remainder, then we will get the first value called A. So here you can see 5 into 4, 20. So this is the B. So this is called Q. So B into Q, 20 plus R. So R is 2. So 5 into 4, 20. 20 plus 2, 22. That is A. So this is the output variables specification. So A is equal to Q into B plus R. Then we are again mentioning the specification for the second output variable called R. So R less than or equal to 0. So it should be less than B. It should not less than or equal to 0. So combining these requirement, we will specify the desired output. Here we will write the specification for the output variable, that is Q and R. So here you can see double dash outputs: A is equal to Q into B plus R, and not less than 0 and less than B. So value of the R should not less than 0, and the value of the R should be less than B. So in the single line we specify the relationship between the output variables called Q and R. So the command starts with the double dash, which we already know. So here we will see the divide A and B, the algorithm divide and A and B's algorithm specification is double dash input A is an integer and B is not equal to 0, double dash output A is equal to Q into B plus R, and 0 less than or equal to R and less than B. So this is the specification of this algorithm divide A and B. So for a simple dividing two numbers, the specification is in this format. So this is the simple method for defining a specification for any algorithm. So I hope you understand this topic specification. Now we are going to see what is the format for writing a specification. So first format, the name of the algorithm and the inputs. First we should allot the name for any algorithm, and input variable and output variable, and property of the input, and desired input output relationship. The first part of the name of the algorithm and the inputs. The second part is the property of the input. It is written as a command which is with the double dash inputs keyword, double dash output keyword. So in this example you can see divide A and B is the name of the algorithm. So divide is the name of the algorithm. So input is the property of the input, output is the desired output input relationship. So here we identify the relationship, exact relationship between input and output variables of this algorithm. So this is the total solution for the divide A comma B. This is how we write the specification for any algorithm. This is a simple example for writing a algorithm for dividing two numbers problem. So now we are going to see write the specification of algorithm for computing the square root. So we already know how to write the specification of any algorithm. Rule number one, we should allot the name for the algorithm. Rule number two, we should know the what are the inputs. Rule and specify the property of the input. Rule number three, we should mention the relationship between input and output. So let us find write the specification for identifying or computing the square root of any number. So here you can see it takes number as input. Of course, if you want to find a square root number, then the number we should take any number. Let us name the input as n, and n should not be negative. So this is the property of the input. So when we try to find the square root of any number, then that number should not be negative. This is the property of input. So property of the input we can specify like this. So double dash inputs, n is a real number. It means the number is a positive number. N should not n greater than or equal to 0 should be greater than or equal to 0. It means n should not be negative number. This is the property of input. So here we mention the square underscore root of n. It means it is the name of the algorithm. Here we mention the second step where we mention the property of the input, that is n, which take as a input. So we are going to find the square root of the number n. Now we are going to find the relationship between the input and output. So consider y as the output. So what is the relationship between y and n? Here you can see it produced the square root of n as the output. Let us the name output y, then n should be the square root of y. So now we write this specification, third step, output, where we mention the relationship between y and n. So y is a real number. Of course, when we try to find the square root of any real number, then we produce the real number as a output. So such that y into 2 is equal to n. So here y2 is equal to n, it means y into 2. So when we divide the output with 2, then we'll get the input. So for example, if you find the square root of 25, then what is the output? The output is 5. So when we multiply the 5 with 2, then we will get the input, that is 25. So that is mentioned here, y2 is equal to n. So y2 means y into 2. We should multiply the output value with 2, then we will get the input, that is n. That is mentioned here in the third step, that is the relationship between input and output. This is the method of writing a specification for finding or computing the square root of a number. Next, specification as contract. So when as a programmer, when we try to develop any software, the customer will give all the necessary inputs or requirement or any detail related to the problem to the programmer. At the time of beginning, right, at the time of beginning of algorithm, that we decide the specification, we identify the specification. So providing the information is the responsibility of the user and right of the programmer. Providing the correct desired algorithm and desired output to the user is the responsibility of the programmer and right of the user. So this is the thing which we discuss here. So when any user or customer asks a programmer to write a program to solve his problem, then what are the inputs he need, that is programmer needs, that input should be provided by the user. It is the responsibility of this user. Then getting a required input is the right of the programmer or algorithmer. Next, after getting the input, then this programmer should produce the correct output or desired output required by the user. This is the responsibility of the programmer and right of the user to get exact output from the programmer. So this specification, that is the input output properties and relationship of input output, it becomes a contract between user and programmer. So specification plays a very major role when we try to develop any software. So at the time of software developing any software, the customer who gives an order, he should give the required input for the programmer, and programmer should get all the required input from the customer. So providing input details is the responsibility of customer. Getting the input from the user or customer is the right of the programmer, and providing the desired output to customer is the responsibility of the programmer. It means if you are programmer, then you should produce the exact output software to your customer. Then only you are a good programmer. Otherwise, you are not considered as a good programmer. So the programmer is the program will become a big programmer or a popular programmer when or she should fulfill the requirement of the customer. So the specification plays major role when providing input or getting input. So try to understand this topic specification, very simple topic. So where we follow three step in specification. What we want to do, first we should allot the name for the algorithm, find the necessary inputs, give the names for the inputs, find the necessary output, give the names for the output. Number two, after allotting the names for algorithm and input output variables, in the second step we should allot the properties for the inputs. So this is the second step. First step, allot the name for algorithm and input output variables. Second step, identify the properties of the input. Third step, identify the relationship between the input and the output. So these are the three important steps in writing specification for any algorithm. So next topic is specification for writing an algorithm, which we already discussed. Now we are going to discuss the abstraction. It means hiding unnecessary details. So excessive information will lead to confusion. So here you take riding a bicycle. It is sufficient to understand the function of pedal, handlebar, brakes, bell. As a rider, we model a bicycle by these four features. A bicycle has a lot more details which the rider can ignore. Those details are irrelevant for the purpose of riding a bicycle. So, whenever we try to solve any problem, we should avoid all unnecessary detail and should understand all the necessary details. So, abstracting means avoiding, ignoring, hiding irrelevant details and modeling a problem only by its essential features. So here you can see the definition. Abstraction is the process of ignoring or hiding irrelevant details and modeling a problem only by its essential features. So in our everyday life, we use abstraction unconsciously to handle complexity. So abstraction is the most effective mental tool used for managing complexity. If you do not abstract a problem adequately, we may deal with the unnecessary details and complicate solution. For example, in our real life life, if you take example, a map is an abstraction of the things we find on the ground. We do not represent every detail on the ground. The map maker picks out the details that we need to know. Different maps are drawn for different purpose and so use different abstraction. That is, the hide or represent different features. A road map is designed for drivers. They do not usually worry about hills, so mostly hills are ignored on a road map. A walker's map is not interested in whether a road is a one-way street, so such details are ignored. So there are different types of map for a driver, for a walker. Likewise, we hide some details for different type of maps. If you take the another real life example, in medicine, different specialists work with different abstraction of human body. An orthopedician works with the abstraction of skeletal system, while a gastroenterologist works with the digestive system. A physiotherapist abstracts the human body by its muscular system. So we use abstraction in variety of ways while constructing algorithms. So in the specification of problem, representing the state by variable, decomposing an algorithm to function, an algorithm desires has to be trained to recognize which features are essential to solve problem and which details are unnecessary. So each and every algorithm, for example, a good when we can identify a good algorithm who can able to differentiate between necessary and unnecessary details of any problem. So these unnecessary and necessary details can be identified at the first step called a specification, which we already discussed. So next we think the important steps in abstraction. Number one, state and function. What is state? In algorithm, the state of computation is abstracted by a set of variable. Function, when algorithm is very complex, we decompose it into function and abstract each function by its say specification. So these two topics which we already discussed in previous session of video, where we learned the state by using a term. Now we will discuss same thing. State is a basic and important abstraction. Computational process have state. Computational process start with an initial state. As action or perform, the state may change. For example, when we try to understand this state, we give an example called the traffic pole. In roadside, we can see the traffic pole. Traffic pole will display three different colors: red, orange, and green. So red, orange, and green are the different state of the traffic pole. So it may vary depending upon the traffic. So sometimes it is in red, sometimes it is in orange, sometimes it is in green. So depending upon the state, we produce for the next level of computation. So state is a value of the variable which we use in the abstraction process or algorithm process. So next is the function. Function, of course, we know dividing a big problem into small problems. Next is the topic called abstracting. Next we try to identify the abstraction concept using chocolate bars. So it is a very common example for understanding the abstraction. So understand this example. A rectangular chocolate bar is divided into squares by horizontal and vertical grooves. We wish to break the bar into individual squares. So what we want to do, and here what are the essential items which we want to know. So what we do, generally we have whole of bar as a single piece. So we cut it into horizontal wise and vertical wise and create a individual squares of a big square. So finally, we get it the individual square of a big bar of chocolate. In this example, we will abstract the essential variables of the problem. We solve the problem in example 8.6. Here, the essential variables is the number of pieces and the number of cuts are the essential variables of the problem. So how much of cut we applied on a single chocolate bar and how much of pieces of very different chocolate squares we get from that process. So that these variables can be named as P and C. So P means pieces of chocolate. C means different horizontal and vertical cuts applied on a single big chocolate bar. Now the irrelevant details. So if you take irrelevant details, that is that should be ignored. So what is the irrelevant details? The problem could be cutting a chocolate bar into individual pieces and cutting a sheet of postage stamp into individual state stamps. It is irrelevant. So here irrelevant is the size of the piece. Size of the piece is the irrelevant for cutting a chocolate bar into a small pieces of squares, individual squares. Because in question he didn't mention the size should be same or size should be mentioned, and so that's why the size is irrelevant to this algorithm. So the size of the bar, the size of the pieces may be different depending upon the cutting, the horizontal and vertical. The size may be vary. The sequence of cuts that have been made on the shape and size of the resulting pieces are irrelevant too. So here size of the pieces of individual chocolate may different. So it is not relevant to the question. That's why this variable is removed from the abstraction. So removed from the specification. So this is called the abstraction. Now we try to understand the abstraction with a real life problem which we already try to understand in the previous video, that is goat grass wolf problem. So when we try to understand this problem, so what we want to do, so there is a two sides of river, one is right and left side. So if you take farmer goat grass wolf, all his members are in the left side of river, then they want to travel across the river and reach the right side of the river. So this is the question. So here what is the problem? In when we travel in the boat, there is only two members can travel. So who are first travel from left side to right, and who should not be alone, who should not be allowed to alone, it then it will damage the other. For example, goat cannot be left alone with grass because goat will eat the grass. So goat cannot be left with the wolf because wolf will eat the goat. So this is how the relationship of inputs and relationship of the output is mentioned, and the properties of the input are carried out. So here the specification for this problem is, first we decide the name of the algorithm, cross underscore river. The first step, name of the algorithm. Second step, input properties of the input variable. So farmer, goat, grass, all these are variables which are in the left side. That's why they mention the letter L because they all are in the left side of the river. So what will be the output? All these variable farmer, goat, grass should be right side of the variable at the end of this process. So that's why the R letter is mentioned here. So here LL mentioned left, R letter gives the representation of the right side of the river. So this is the two important specification mentioned here, where we try to name the algorithm as cross underscore river, and try to set the properties of the input farmer, goat, grass and wolf, and try to set the desired output of the algorithm, that is farmer, goat, grass and wolf is equal to R. So these are the some of the condition where we cannot allow goat with grass, goat or goat with wolf. Now when we try to understand the same thing with another example, assignment statement. So of course variables are the named boxes to store values. We know how to store the values. We use colon with is equal symbol to store any value to the variable. So the syntax is mentioned here. You can see variable colon is equal to value. Right side is the place of value. Left side is the name of the variable. So m colon is equal to 2 means 2 will store in the variable m. So variable is the name of the memory location or memory box of the system. If the variable already has a value stored in it, assignment change its value to the value on the right side. For example, if the variable m is already have the variable of the value any other value, then it will replace the assignment statement will replace the old value with the new value. So the old value automatically lost from the variable. So each and every time whenever we use the assignment statement, we should be clear that the variable which we try to store any value, new value, should be empty, or it should contain the value which is not necessary for the program. If so, assignment statement, you can see here m is equal to m plus 3. So here assignment statement add the values after executing the expression. So in the previous example we see m is equal to 2, where the value 2 is directly stored in the variable. Here you can see m is equal to m plus 3 means after executing this expression, the new value is stored in the variable. So assignment will always execute at the end of the expressions. So m is equal to m plus 3 means first m plus 3 will execute, a new value is generated, and the new value is stored in the variable m. So in the same way, m plus is equal to 3 is equal to 2 plus 3 is equal to 5. It means we can use variable name with the values. So here we use m plus 3 means we use the variable which contains all the value 2. So 2 is added with the 3 and it is stored in the variable m. So at the time of executing all this statement, the final value of the m is 5. The two sides of any assignment statement are separated by the symbol colon is equal to. So this is called the assignment operator, or becomes operator, or is assigned. So it read as a becomes, v becomes e. So v is equal to e. We can say v assignment is equal v assignment a, or we can also say v becomes e. So v becomes e means value of the e is stored in the variable v. So now we try to understand the assignment statement with an example. So in example you can see what are the values of variable m and after the assignment in. So here in the line number 1 and line number 3, we want to identify the values. So in line number 1, after executing the statement, we can say value of the m is 2 and value of the n is 5. It is simple. Here when we execute this statement, the third statement, what will be the output? So value of the m is already 2. So 2 plus 3 is 5. So now the value of the m is 5. So value of the n is 5. So n minus 1 is 4. Now value of the n is 4. So value of the mn is 5 and 4. So here you can see the output. So m plus 3, n minus 1. So m contains already 2, 2 plus 3 is 5, and n already contains 5, 5 minus 1 is equal to 4. This is how the assignment operator executed here. So we will try to understand the assignments operator with a second example. So we abstract the state of the process by two variables p and c at the time of cutting a chocolate bar. The next statement is to model the process of cutting chocolate bar. When we make a single cut of piece, the number of pieces and number of cuts both increase by 1. We can model it by an assignment. So whenever we try to apply any cut on a chocolate bar, then what will happen? We can write it as a assignment step. So whenever we apply any cut, then number of cut will increase and number of pieces is also increase. That can be written, that can be write like this. So p comma c is equal to p plus 1 comma c plus 1. Here p represent the pieces, number of pieces, c represent number of cuts applied on the chocolate bar. So this is how we use assignment statements in algorithms. So I hope you understand the different problem solving techniques, algorithm techniques like specification, abstraction, composition, and decomposition. So prepare the answers of this question and book pack questions and submit it through WhatsApp. If you have any doubt, contact me through WhatsApp. Thank you. Assalamu alaikum.